Hi, my name is Asim. I'm with the product management team here at Barracuda Networks. Today, I'd love to show you a demo of the Barracuda Load Balancer ADC. Let me tell you a little bit about the product first. The Barracuda Load Balancer ADC provides Layer 4 and Layer 7 load balancing services. In addition, it provides application delivery features. Through the course of this demo today, I'd love to show you all the major features as well as some of the benefits that the Barracuda Load Balancer ADC provides to your organization. The one thing you want to remember is that all these demos are accessible all the time with the username guest. No password is required. Let's try to log in now. What you're looking at here is the interface of the Barracuda Load Balancer ADC. It's a demo machine, so it has some demo statistics. Let me walk you through some of the elements that you're looking at here. Now, on the left-hand side, you're seeing web requests. So, for example, in the last 1 hour, there was 4,699 web requests. Now, if I go to the right-hand side, it shows that this is an appliance. Everything is working normally. And if I click on details, it shows me much more details about the appliance. So if I wanted to know the temperature, the CPU fan speed, and other such details, I can find it here. Let me scroll down a little bit. It shows me high availability status. Now, it goes without saying, the Barracuda Load Balancer ADC does support high availability. Now, it goes without saying that the Barracuda Load Balancer ADC does support high availability as well. Now, I'm going to scroll down a little bit more, and what you see here are different network interfaces that the system has. What you see here is a visual representation of all the network interfaces in the system. Now, depending on the model that you have, your system will have anywhere up to 8 1 gig interfaces and 2 10 gig either fiber or copper interfaces. In this system, you can see 2 10 gig copper interfaces as well as 8 1 gig copper interfaces. Depending on the model, this configuration can vary quite a bit. If you continue scrolling down, you see some more data. Some of that is in graphical form, but let's keep going down here. Now, if you continue scrolling down, you see things like cache efficiency. Through the course of the demo, we will get to where we can talk about caching and compression. Now, the only other thing I would like to highlight on this page is that this is a configurable dashboard. All of these settings can be changed. What you see on the screen can also be changed. Now, let's actually get to the nuts and bolts of the product. In a load balancer or an application delivery product, the very first thing you have to do is create a service. What that means is you assign what is known as a virtual IP to your application. That virtual IP that you're assigning to your application is what fronts the traffic. Of course, on the back, there are multiple servers where all the traffic is being load balanced to. So let's get started. I am going to create a new service. I'm going to begin by clicking on the services page here. As you can see, there are already a few services here, but I'm going to hit the button that says Add Service. It's a pretty simple process to add a new service. The name of the service is My Application. Of course, you can choose your own name. I have to decide what kind of service this is. As you can see in this drop-down, a service can be of many types: HTTP, HTTPS, FTP service, Layer 4 TCP service, Layer 4 UDP service, among many others. Now, we are just creating a simple HTTP service today. The IP service here is the virtual IP that will front all traffic. I've entered the IP address, and if you scroll down, you will see that there are a lot more settings, but we will get to that in a second. The information that we have just entered is all that is needed to create a new service. Let's go ahead and do that now. Creating a virtual IP is one of the 2 steps that's required to create a new service. The second step is to go ahead and add the servers at the backend. Let's do that now. I already know the IPs of my server, so I'm going to add them. There you go. We've just created our very first service. What this page shows us is a service called My Application, which is of the type HTTP, and it's running on 192.168.20.30 on port 80. This service has two servers backing it. These two servers are 192.168.10.19 and 10.20. Now these little icons, the green icons, show you that everything is good. Of course, the next step is to actually try to access the application. But before I show you how we do that, I want to talk to you about something very important. This, as I said earlier, is an HTTP type of service. But if we go back and try to take a look at the types of service, you will remember one type of service is HTTPS. Now what that means is the Barracuda Load Balancer ADC can terminate SSL connections. That's a very important feature. It's beneficial for a number of reasons. For example, if you want to offload all SSL handling to the Barracuda Load Balancer ADC, you can do that. Now you might be wondering, why would you want to do that? There are various benefits of doing something like that. First of all, if all SSL handling is done by the ADC, then your servers don't have to do the heavy lifting. In addition, if you have many servers and you're worried about handling SSL certificates, revocations, and things like that, by consolidating SSL handling in the ADC, you actually simplify the administration. If any one of your certificates needs to be replaced, updated, expired, you don't actually have to go to all of your servers and do that. In fact, you can just do that in one place in the ADC. It allows the ADC to inspect traffic. It allows the ADC to look at packets and apply any policies that you might have set. In addition, if there are any security threats, the ADC can weed them out as well. Now that we've talked briefly about SSL offloading, let's go back and use the service that we've just created. I'm going to open up a new tab and access this service by going to the virtual IP that I assigned to my service. If I look at the screen, the IP is 192.168.20.30. So if everything worked well, I should be able to access my application. Voila! The application is now being served through the Barracuda Load Balancer ADC. Let's take a step back and talk about what's happening here. Through my browser, I'm hitting the VIP or the virtual IP that is hosted by the ADC. The ADC terminates the connection, acts as a reverse proxy, and then sends the traffic back to one of the two servers that we just added. Now let's play a little game here. Let's try to find out which server did the traffic go to. What I've done for the purpose of this demo is insert a line on this page that shows you which server is this coming from. So if you look carefully, it shows this is from server 1. Let's go ahead and refresh the page and see what happens. Now this time it says this is from server 2. So every time I go back to access the application, the traffic is being sent to an alternate server. We could keep doing this again and again, and you will notice that every time the traffic is alternating between server 1 and server 2. So let's go back to the ADC and talk about why that is happening. This is the service that we had created. Let's scroll down a little bit. If you look at this, you can see that the load balancing algorithm here is round robin. And that explains why every time I hit the VIP, the traffic goes to a different server. That's what round robin means. Okay? But now that we have accessed the applications, erase that last sentence, end of topic, next topic, accessing the logs on the product. Now that we have accessed the application through the VIP on ADC, let's see if there's any logs that the ADC maintains. I'm going to hit the access logs page here. As you can see, all traffic that has been going through the load balancer ADC is logged here. Now in this case, I see the client IP, the service IP and port, the method, as well as if I want to see details of that traffic, I can see it here. The ADC also has audit logs that records all the changes done to the system for purposes of auditing. Let's take a look at that. Now the very first line tells me that the server IP was added, and that happened when we added a new server here. And that happened when we added a new service here. Just like in the last page, there is more details for each of these log entries if you would like to see them. Let's talk a little bit more about how our application is being served. Now, just now, I discussed with you that we are using the round-robin algorithm for load balancing. That works most of the times, but many modern applications have a concept of session as well as they require persistence. What that means is they expect a user to have affinity with a server. So all traffic from a user should go to the same backend server. So in that case, this round-robin algorithm will not work. But the load balancer ADC can be configured to do session persistence. I'm going to go back to the services page and change some settings so that all traffic from this user will go to the same server every time. Let's scroll down. Let's take a look at this setting where it says persistence type. If you look at the elements in the drop-down, you can see source IP, cookie insert, cookie passive, HTTP header, and URL parameter. Now, all of these are different ways of doing session persistence. I'm going to select cookie insert, and what that means is that the load balancer ADC is going to insert a cookie the very first time a user accesses the application. All subsequent accesses will go to the same server because the ADC knows where to send it based on the information in the cookie. Let me hit Save Changes, and then we will go back to our application and see if this is really the case. Okay. Now, if I hit refresh, let's see what happens. So this time, the data is from server 1. If my persistence value was actually saved, then all subsequent accesses should come back from the same server, server 1. Again, as you can see, the data is coming back from server 1. Let's try it one more time. So that's the concept of session persistence. Now that we have talked about session persistence, let's take a look at some of the other features provided by the Barracuda Load Balancer ADC. One of the many valuable features in the product is the ability to do caching and compression. It's really easy to enable caching and compression for web applications on the ADC. All you have to do is change the setting from off to on, and by default, what it's going to do is cache all files that are between the size of 256 bytes to 256 kilobytes. Those cache items will be held in the cache for up to 60 minutes. And you can see that right here. Similarly, all traffic that is larger than 8 kilobytes will be compressed before it is sent to the client. Now, all of these settings can be changed very easily. But let's not change those settings for now and just go ahead and hit Save Changes. The net effect of enabling caching and compression on web applications is to speed up your application dramatically. In addition to caching and compression, another very powerful feature of the Barracuda Load Balancer ADC is the ability to route content based on policies that you set. Now, if it's an HTTP application, the traffic is already in clear text, so there's no problem. If it is an HTTPS application, this is where the value of SSL offloading comes into play because the ADC terminates SSL connections, so now it has the ability to look inside that traffic and apply policies and send traffic as directed by you. Let's go ahead and create a content rule. So again, so like with everything else, it is easy to create content rules. Now the example that I'm trying to show here is I want to send all traffic coming from iPhones to a different server. So let's give this content rule a name. Now, what I've done so far is just create a very simple content rule that applies to all traffic. But like I said, I only want it to apply to traffic coming from iPhones. Now, if you look at extended match, you can see these policies can be very, very granular. These policies can be applied to client IPs, headers, HTTP headers, method, parameter, path info, URI, you name it. I'm going to select header. I'm going to select the element name to be user agent, and then of course is equal to. I'm going to enter the value for user agent for browsers on the iPhone. And that's it. Once I hit insert expression and hit save, I have a content rule that isolates traffic coming in from iPhones. And now that we have a way of isolating traffic coming in from iPhones, we have to decide what do we do with it. Now in this case, let's go ahead and say that we want to send that traffic to a particular server. Now, that's easy to do. We have a content rule. We just have to add a server to send the traffic to. And that's it. What we've just done here is we have created a rule to isolate all traffic coming in from iPhones and sending them to a special server. Now, this has various benefits. This can be used in many ways, but we can actually extend this concept. Instead of just trying to isolate and redirecting traffic to a particular server, we can do some rewrites. Let's take a look at that. If I go to the page that's under traffic and click on web translations, you can see the ADC can rewrite both inbound traffic as well as outbound traffic. If you want to rewrite headers, HTTP headers, you can do that. This is an example of a header rewrite rule that I've already created. And all it says is that for any traffic that's coming in, the ADC will insert a header called xforwarded4, and it'll insert the source address of the IP into that packet. In addition to rewriting HTTP headers, the outgoing traffic, the HTTP response, as well as the response body can be rewritten. Various use cases for all of that. Throughout the process of creating this service, we haven't talked about one very important aspect, which is how does the ADC know when any of the backend servers or the applications that are running on the backend servers are available or when they're not available. In fact, the Barracuda Load Balancer ADC has a whole host of application monitors that do just that. I'm going to go back to the basic services page and let's see what options we have for monitoring backend applications. If you look at the section that's called Service Monitor, you see a large list of different ways in which the ADC can monitor your backend application. Something as simple as TCP port check is there, but if you have different applications, maybe web applications, IMAP, POP3, SMTP, for each of these applications, the ADC provides a custom way of monitoring your application. By now, our application is fairly well configured. It's time to start thinking about how do we restrict access to our application. In other words, how do we ensure that users have to log into the application before they're actually given access? Let's take a look at that. I'm going to the Access Control tab and clicking on Authorization Services. The Barracuda Load Balancer ADC allows you to integrate your application with Active Directory, LDAP, Radius, and Kerberos for authentication, authorization, as well as single sign-on. The nice thing here is you can do all of this without changing a single line of code in your application. If you look at the screen, I already have an LDAP set up. Let me just enable that for my application and see what the behavior is. Now that we've enabled authentication on our application, let us see what happens when I try to access it. We have just integrated our application with an LDAP server. So now a user has to provide username and password before they can access the application. And we did all of this without making any changes to our application. Of course, this was a very simple example where the entire application was put behind an LDAP server. But a more likely scenario is you will be protecting various parts of the application and only providing access to parts of the application to a certain group of people. All of that, again, can be done using the authentication and authorization facilities provided in the Barracuda Load Balancer ADC. By now, we have configured our application just the way we want it. If any one of these servers dies, traffic is then automatically sent to another server and things like that. If any one of the servers dies, traffic is automatically routed to another server. That's great, and it provides high availability inside one data center. The question to ask now is, how do we protect against a natural disaster where the entire data center is unavailable? The Barracuda Load Balancer ADC has a feature called Global Server Load Balancing that does just that. Now, if I go to the page under Traffic and GSLB Services, you can see that there are three types of GSLB services that are provided. The three types are GeoIP, Region Only, and Priority. What this really means is that if one of the data center dies, traffic is automatically routed to an alternate data center. When both the data centers are active, traffic from a user is sent to a data center that's physically closest to them. That means the end user experiences much faster page load up times. Unlike other vendors, Global Server Load Balancing is not an extra charge with the Barracuda Load Balancer ADC. There is one final topic I'd like to talk to you about. Our application is configured properly. If any one of the servers dies, there's no problem because the ADC will redirect traffic to another server. If there's a problem with the data center, using Global Server Load Balancing, all of the traffic will be sent to another data center. We've enabled things like caching, compression, session persistence, as well as authentication and authorization. What we have not talked about is security. And once again, the Barracuda Load Balancer ADC provides Layer 7 application security. This is very distinct from the security provided by our firewalls. What the Barracuda Load Balancer ADC provides is Layer 7 application-aware security. Let me show you an example of that. I'm going to go to the Security tab on the product. What you see on this screen are various settings to protect your application from unauthorized access, from targeted hacking attempts, and such. Now again, keep in mind, the Load Balancer ADC provides an additional layer of application-aware security on top of the services and protection that you're already getting from your firewalls. If you wanted to protect against cross-site scripting, SQL injection, you can do all of that with the security provided by the Barracuda Load Balancer ADC. We have seen a complete demo of the Barracuda Load Balancer ADC. Hope you found it interesting. If you have any questions, please ask them by clicking Ask a Question button on your player. Thank you very much.